Good afternoon, everyone, and a warm welcome to this session where we have a distinguished expert panel looking at the role of AI in the agriculture domain and some of the radical changes in the sector that the deployment of AI technology is going to drive in the coming years. My name's John Davies, and I'll be chairing the session. In a moment, I'll ask the panelists to introduce themselves. I'm a senior manager for future business research at BT, where I lead a team looking at a number of technologies, including IoT, data analytics, and blockchain, and their application in a number of industry verticals, including, of course, agriculture, where BT is a key partner in the Robot Highways Consortium, which is aiming to deliver the world's first carbon neutral and fully automated soft fruit farm. In terms of my personal link to agriculture, I grew up in Kent, the Garden of England, as many of you know. And I've picked just about every type of soft fruit known to man, as well as spending an enjoyable summer when I was a student as a tractor driver on a farm down there in Kent. Now I'd like to ask each panelist to introduce themselves, their background and their involvement in AI and agriculture, and perhaps say a bit briefly about how they see the future of agriculture in this context. So let's go to Simon Pearson first. Over to you, Simon.
Yeah, thanks, John. So I'm Simon Pearson. I'm Professor of Agri-Food Technology at the University of Lincoln and Director of Lincoln Institute of Agri-Food Technology. So I've got a background a bit like John, really. So my father was a farmer, so I grew up on a veggie farm, actually. So whilst John was picking fruit, I was picking veg. So we've got a basket of fruit and veg between us. So I've driven every agricultural vehicle you can imagine as well. And then I went off and did a PhD at Reading, went and worked for Marks and Spencer as a technologist, so at the supply chain end. Then I ran a farm, then back to the university. So I've got sort of rounded experience. I now run a significant group at Lincoln. We are known for agriculture robotics, but also data science and AI in agriculture. It's quite a significant group. We've got a pipeline of about 65 PhDs now with jointly Cambridge and UEA in agri-robotics. So we're looking for talent. So anybody out there who's listening and is interested, please get in touch. It's a wonderful, wonderful career and a great place to be. These systems are transforming agriculture. And with John and Lars, we're involved in the Robot Highways project. We're involved in the robotics, the control. Now, why AI and robotics? Well, robots are actually the hardware and AI is the software. And so it's AI which is controlling all these robots. It's AI that is transforming agriculture. So we're very, very excited about the opportunities for AI in agriculture, particularly for robotic control, but also for understanding agriculture. So it's going for a transformation, and the power of data will help transform it. It will improve labour productivity, but above all, reduce carbon use, pesticide use, nitrate runoff, and all those things that we need to think about as a society.
Thanks a lot, Simon. Now I'll pass over to Lars, our second distinguished panelist. Lars.
Thanks. So I'm Lars Grimstad. I'm co-founder and CTO of Saga Robotics. That's a Norwegian agricultural robotics company. I'm also an associate professor at the Norwegian University of Life Sciences, so I do some teaching as well, although not too much these days, as Saga is definitely my day job full-time. So the Saga Robotics was a spin-off from the research group, robotics research group at the Norwegian University of Life Sciences. My background is mechanical engineering. I did a PhD in robotics, very much on the hardware side. I have to admit I'm definitely not the main AI person in Saga Robotics, although we have very strong assets on in the company. So basically, Saga Robotics started up in 2016. Almost from the very beginning, we had a very close collaboration with Professor Simon Pearson and his guys. They're looking for talent, but I can confirm there are definitely a lot of talent there already. I've had a lot of cool projects with them, a lot of them financed through Innovate UK, as our project with BT as well is now. So a lot of fun there. So what Saga Robotics do is that we have these mobile robots that we deploy on commercial farms. So our focus is kind of to take the technology that we started on at the university and get that into real farms. Our main focus is in strawberry and wine at the moment. Our first commercial application is that we treat plants for mildew using UV lights. So basically we have basically a sun bed, like a tanning bed on our robot, slightly different wavelength, and we drive back and forth, or the robot drives back and forth all night long autonomously. We do this in Norway, we do it in the UK, we do it in the US commercially. We also do trials in Italy and in Germany, in Greece this season. And other applications that we look or are developing is like we have a strawberry harvesting robot, also together with University of Lincoln, where we have computer vision guided robotic arms that pick strawberries. Definitely AI driven. Yeah, and I guess for my background in farming, I'm not a farmer. I grew up on a farm, but there weren't any farming activities happening. I did drive a tractor around though. Yes. So that I can do. And when it comes to like AI and robots in agriculture, I would say that we've had robots in industry for decades, and AI is what is critical to kind of when we're porting that technology from the clean and kind of structured factory environment into kind of the messy, unstructured farming environment. So yeah, so that's me.
Thanks, Lars. I just wanted to pick up very quickly the UV thing you mentioned. I think is a nice one, because if I'm right, correct me if I'm wrong, but that's something that's quite difficult in a way to do with humans. And you can go very slowly up the rows of strawberries or whatever fruit with a robot and very methodically apply the UV to destroy the mildew, which, if I'm not wrong, would be quite time intensive and difficult to do in a uniform, good quality way with humans. So I think that's a really interesting example. Yeah.
Definitely.
Yeah. Anyway, yeah, thanks very much for that. Thanks, Lars. And now over to you, Kevin.
Hi, thanks, John. I'm Kevin Gooding, and I'm the founder and chief executive of a company called Diometer. We are a young company, part of the Innovation Marketing Cluster at Industrial Park. We are actually in the final stages of developing the first version of our new virtual farming platform. We loosely sort of use the phrase digital plumbing for innovative farms, which I think probably sums up a lot of what we're trying to do. And I think you can see from that, from an AI perspective, we come at it more from the data end. So we're about getting all the data together as much as anything else. And I have to say, in the short term, we don't do a lot of AI today, although we do anticipate doing more of it downstream. We're due to go live with our first trial around about Easter. We're just finalising the actual date with a large estate in Suffolk, the Euston estate in Suffolk. It's about 10,600 acres. So we'll be testing the system out, and the first version of it from Easter. In terms of my background, like everyone else here, actually, I've had some involvement with farming. I come from a farming family. I was even a member of the Young Farmers Club in my youth. Although I have to say, I've had a career in technology, but there's always been a bit of agriculture, I think, in my DNA, which is probably why I've created Diometer more recently. I'm also a council member of the Suffolk Agricultural Association, and which is interesting given I'm not a farmer. And one of the reasons they asked me to become a council member there was because of my understanding of the technology sector, which is something they're very aware of. It's something that is hitting agriculture in a big way. In terms of AI in agriculture, I think historically it probably started being used properly in precision farming type stuff, where you get drones and satellites, etc., and sensors and things collecting data, so that when you allocate spray, when you're spraying a chemical of some sort onto a field, hopefully you're pinpointing it in a better way. You use less of it, so your costs go down. At the same time, you don't put the wrong stuff on the wrong plants, etc., and you get better yields and all the rest of it. But the takeoff, in my view, has been slightly slower than I think everyone thought it might be, although it is becoming more mainstream. Increasingly, I think AI is being used in management decisions, and we've just seen some of that, and we've been talking about it already here, I think, but also we just saw some of it when Chris Newnham was talking about Wilkins and what they're doing. And also more and more automation is coming along, and clearly Lars here is probably more of an expert on that than I am. So you've got the vertical farming, controlled environment farming, the whole sort of issues of automating the picking of particularly things like fruit and vegetables. Although, I mean, from my own perspective, I tend to look more in the arable sector, and there are other robotic businesses like a small robot company which is building some robots to look at arable farms, being able to pinpoint individual weeds and that sort of stuff. But what I always say to people is AI, or other robots need AI. I think we've already had that message, but AI needs data. And it's actually the combination of all these things which comes together. So I think one of the key things I would say about farmers and their take-up of AI, or what would help them, actually, I was watching Joe Spisak this morning, and he said something which is pretty obvious, really, but that's the first time I've really heard of it. But usability is king, the phrase he used. And I think that's really quite critical for farming. Because the average farmer is definitely not an AI expert, even if they're digitally literate, and so they don't need to understand the AI. What they need to understand is the ability to make decisions in their farming operations. So usability really is king. And I think also the other thing about AI, we've already talked about a lot of different things it can be used for, but there's also a lot we haven't talked about, and we haven't really talked about livestock much, for example. And I think farming is a very, very fragmented industry. It's quite a challenge from an AI perspective to develop solutions which are going to be broadly available right across an industry which is very fragmented. So, but the final point I was going to make about AI is that agriculture is changing very fast at the moment. If you take the UK, subsidy system is changing, which is dramatically changing the whole way farmers run their businesses, and will do. It's going to be an evolution because it's going to take until 2028 before the basic payment scheme is completely phased out. Another major thing that's going on in farming, which you might well have heard of, is called climate change, which is already impacting farmers in a big way. And then finally, the broader sort of environmental pressures that farmers face today. And we hear a lot about that during the pandemic as well. And on top of that, by the way, there's a new thing called technology coming along. In 10 years' time, farming is going to look very different from where it is today.
Yeah, thanks, Kevin. Thanks for that introduction. Very, very thought-provoking. And in fact, we're going to pick up on one of the last points you made there and go. I'm going to come back to you first with the first question, which is what's the impact of climate change on agriculture, and how can AI help mitigate any negative impacts?
Maybe the best way to talk about is examples. And probably one example I think is one I've come across quite a lot in East Anglia in terms of arable farming. If you look at arable farming in East Anglia and you go back to 2019, arable farmers in East Anglia, which is probably the breadbasket of the UK, actually had their highest yields ever, roughly sort of 10% up on the previous year. And which was interesting. When I spoke to farmers about it and said sort of why, what happened, what did you do differently, 99% of the time you get the same answer, which is it rained at the right time and it was sunny at the right time. And then interestingly, last year, and we've had a pandemic year, but probably most of us will remember, certainly in the UK, that we had a very nice, warm, dry spring. Great for a pandemic. You could get out and walk around the countryside and things like that. Wasn't so good for farmers because last summer, arable yields were down versus the year before by about 20 to 25%. And the reality there was that, again, it was because this time it rained at the wrong time, it was sunny at the wrong time. So they need a bit more moisture in the spring to let the plants become more established, let their root systems become more established, and then they want a drier time in the run up towards harvest. So I mean, that is a very good example. And when you think of yields changing by swinging by that much year on year, then you start to think, well, okay, if AI is going to come along, I mean, I've discussed precision farming with a number of farmers, and most of the ones that have sort of tried it and tested it out talk about 1, 2, 3% type yield improvements as a result of using that. But when you're getting 10, 20% changes in yield due to the climate, if you're a farmer, where do you focus your attention? So there's a challenge there, I think, and I think that's probably a good example of climate change.
Mm. Yeah, thanks, Kevin. That's a really striking example, isn't it? That variability across 2 years, and how important climate is to yields and other agricultural kind of features, if you like. Simon, Lars, anybody else want to come in on that particular point around climate change?
Yeah, I have it. Yeah, I think the key word is uncertainty. It's where AI really comes in. And as climate's varying, it's creating more and more uncertainty. So, there's more variance in the weather, there's more fluctuations in the weather, events that we've never seen before. So I spoke to one farmer this year, actually. He said in the last 10 years, he's had 6 1 in 100 year weather events. If you think about it. So that's creating massive uncertainty. Where AI comes in is really starting to understand the system so that it can help farmers through that uncertainty. And whilst we really understand some of the main things that affect the way that crops grow, so temperature, light, rainfall, all those fertilizers, all those sorts of things, we really don't have the foggiest how all those things interact. And so our empirical knowledge of the agricultural system is really actually amazingly limited. Good science under it, but very limited. But those interactions which are creating that uncertainty, we don't know. So the ability to get that data and use AI to really understand the system is going to be one of the things that is going to drive resilience for those farmers. So better decision support, timing of operations, maybe they just won't plant in certain years, maybe they can change this, etc. So there'll be a lot of support that farmers can have as long as we start to use AI. The power of AI, which is the understanding the data to understand the system, that will be a good thing. Whether it's good enough, given the extent of the climate change that we're going to get, time will tell, and I think that's worrying everybody.
Yeah, I mean, that's, who knows, I guess, on that one, and that will be impacted by carbon reduction measures that are taken globally and all of those sort of mega trends, if you like. But I'm going to come to Lars. Before I come to Lars, I'm just going to turn it around a little bit from the impact of climate change on agriculture, and kind of conversely also throw into the pot, if you like, what about sustainability and environmental impact of agriculture itself, and how can AI help agriculture to be more green, essentially? So over to you, Lars.
Yeah, I think that's an important point, right? Because of course, like, climate change has a huge impact on farming, but it's also kind of true the other way around. So farming, I think about 20% of the global anthropogenic greenhouse gas emissions come from agriculture. So that's 20% of the kind of emissions from human activities. And I think a lot of this is of course due to the way we farm. Historically, we've tended to kind of treat entire fields as if everything is kind of the same, that a complete kind of a field is homogeneous in a sense, and not kind of treated for local variability. And I think that's where kind of AI comes in and can really kind of change things, is that we now have the ability more and more to kind of to work on a smaller scale, like, or treat for kind of according to local variation. And you see that in a lot of new robotics startups and even kind of established companies as well, that they're looking into this. You have a lot of companies looking into kind of mechanical spraying, mechanical weeding, kind of identifying every single weed and treating locally, getting rid of that individual weed instead of kind of treating the whole, like spraying the whole field, right? And this kind of the fact that we now can kind of start to focus in at that level, I think will be very important. And you see, like, even like these big companies like John Deere, for instance, who have kind of acquired, I guess a few years back, they acquired this company called Blue River for a very large amount of money. And this is a company that kind of had a few prototypes that could kind of do precision spraying. So it shows that even like some of the really big guys are kind of looking into kind of increasing the precision of what they do.
Yeah, no, that's really interesting. I mean, the idea that, you know, you have robots that can, instead of spraying horrible chemicals on fields, they can actually pick out individual weeds and do that quickly enough and efficiently enough to make it a better option is fascinating and clearly a real benefit, and great to hear as well that some of the really big players like John Deere are getting involved in that kind of future technology. Simon, Kevin, anything you'd like to add around sustainability, environmental impact and so forth?
Simon, do you want to go?
Yeah, no, I agree with Lars. So yeah, 21 to 37% of all greenhouse gas emissions anthropogenic gas are from the agri-food chain. So we won't deal with climate change unless we deal with agriculture. Now, unfortunately, it's quite complicated because a lot of that is a natural byproduct of agriculture. We've all got to eat, so it's a cracking problem. So so you've got respiration from soils, methane from cows, and all those sorts of things, which are biological processes. But we've just got to deal. We've got to deal with it. We've got to improve it. Again, I think AI is really important. The notion is sustainable intensification. So what we want is a situation where actually we drive productivity on the best land, where we have less impact on the environment. So we're using AI to make better decision on where we farm. And then the bits where we shouldn't be farming, which quite frankly is a relatively large amount of the United Kingdom, we shouldn't be farming. So we should be, that should be restored or put back or de-intensified in some way. This is the argument. I accept it, but we need AI to tell us where and where not to farm, and that's a data-driven information. That's a data-driven decision that we need. So if we can make those choices, we can do something about these big climate change impacts, and we really need to do that quite quick. But the technology, it really is accelerating up. It's let's get off the worst land where we shouldn't be, get onto the best land, and get productivity driven and get it optimized, and use AI to help that productivity drive.
Okay. I just very briefly add to that in addition to deciding which land we farm, farmers are also introducing new methods of farming. So, for example, minimum tillage farming, things like that, where you disrupt the soil less and that sort of stuff. And a lot of that will impact sustainability and the environmental aspects of what's going on a farm. But again, they need that information. So I sort of completely agree with Simon. You've got to have the management information in the first place to be able to make those decisions about how you do it.
Yeah. Thanks, Kevin, and thanks indeed, Simon and Lars. So, coming to Simon on this one, then my next one was really around yield optimization, and when I was doing a bit of research ahead of this panel, I realized that optimization is not at all the same as maximization. and that's probably obvious to people who've been working in agri-tech as a specialism for a while. But I thought it was a very interesting kind of observation. But anyway, the question basically is how can AI help with yield optimization, Simon?
Yeah, well, I think it comes back to what Lars said earlier. It's what we've done in agriculture, and agri in Latin is cultivation of fields. And so you think of the field as the unit of production. Horti in Latin is the cultivation of plants. What we've got to do is get from the cultivation of fields to the cultivation of plants. And that's the key thing. And that's where AI can really do it. So it's using image analysis, machine learning, looking at every single plant and treating it as an individual rather than a part of the population. That's AI in its finest, and that's precision agriculture as well. So we've got real challenges how we get up there, because the data scale, you can imagine, it's vast, and that's about the processing, the data, the storage. As John knows, telecoms, how do you get that data around the site? And we're working with BT on the 5G application as well. So it's how do we converge all of these things together so that we can actually look at individual plants, not fields. That's how we're going to maximise yield and optimise yield. So yeah, very exciting. A lot of technical challenges, but that is definitely a direction challenge.
Anybody else want to chip in on that one?
I would just add in that in addition to plant, there's also soil, which we should absolutely not forget. Soil arguably is the biggest asset that a farmer has, and must be managed properly. I mean, forward-thinking farmers are talking about leaving their soil in a better condition when they part on their farm than it was when they got it. And that has not happened historically. Interestingly, one of the reasons why it hasn't happened historically is because of I mean, I don't want to be political about this, but successive governments over decades have been incentivizing farmers for land they farm in, whereas what we're about to move to, the new environmental land management scheme in the UK, will incentivize farmers for doing things which, I mean, public money for public goods, as they say it. And interestingly, food is not considered a public good in that definition. So it's all about the environment and sustainability and things like that. Specifically on the yield question, I would also point out that historically, that also partly from subsidies was about yield maximisation, so producing as much as you can, whereas increasingly it's about profit maximisation today. So they're tending to reduce yields a little bit, maybe using different farming technologies and methods and things like that, but at the same time reducing their costs by even more. So if you can put less chemical on a field because you're using AI or you're using robots or whatever, then you can maximise your profit and actually increase it relative to where you have been in the past, even with your yields down on where they have been in the past.
Simon, I think you wanted to come back.
Well, I just thought that's a brilliant point, because on soils particularly, because the world's largest carbon sink is soils, and the world's largest sequester of carbon, it's plants. So clearly, if you put the two together, you know, it might suggest there's a good way on the climate change thing as well. And dead right, I completely agree on soils. Yeah.
Okay. Actually, soil is great because I'm turning now to some of the questions coming in from the audience, and we've got one here. Is there any work being done with AI/agriculture around soil erosion issues? So, you know, are there specific areas where AI can help with soil erosion in agri-tech? Who wants to take that one first?
I saw something on Twitter recently about there being a lot of rain in a very short period of time, and someone had taken a photograph of a field which was very badly eroded in terms of soil erosion from it. But and the person who posted the thing on Twitter basically said, shouldn't the farmer be condemned? And there was a massive reaction from the farming community, who pointed out that they were doing, the farmer who was actually farming it, and you could tell this from the photographs, was actually doing all the things they were instructed to do, they were advised to do when it came to soil erosion. And I think what that said is that the agricultural community needs help, rather than pointing the finger at them. It needs help about it. So soil erosion issues is a big one, and should be taken account of. The other thing I'd say about soil erosion, to some extent, there's a broader issue about water and things, and potentially wind, I suppose, as well. But if you look at water, we tend to manage water on a farm-by-farm basis, whereas what we should probably be doing is thinking more and more about managing water on a catchment area basis, which would include multiple farms and things like that. It is beginning to happen in some areas, but that also will potentially help soil erosion type. Well, but AI has a core part to play in this, because all of these things require a real understanding of what's actually going on, and that's where the AI piece comes in.
Okay. Yep. Thanks, Kevin. So another question coming in from my colleague Sam Watkins, who did some work on robotics at university. In fact, I know back in the late 90s, I think it was, so a while ago, but very interested to understand how the strawberry berry picking will work in practice, and whether haptics is a part of that. You know, the ability of the sensor, the actuator, to sense when it's grabbed a strawberry so that it doesn't squash the strawberry, or is some other technique used these days? So Lars, clearly one for you, I think.
Yeah, it's an interesting question, because there are quite a few companies looking into trying to develop strawberry harvesting robots. And one thing that is interesting is that they have all kind of different approaches to how they pick the strawberries. So some companies, they try to have tried out kind of snap picking, similar to what a human does. So you basically pick the strawberry and you snap the stem. While other companies use kind of more like scissor mechanisms to cut the stem and so on. So I don't think I don't think the answer to that question, like what technique is the best, is has been answered. But there are definitely a lot of different methods being tested. So for our strawberry harvester, as an example, we also looked at different techniques. So the gripper we use the most, we basically have the gripper kind of open up and kind of swallow the strawberry without touching it, and then we have kind of picked it inside the gripping head, because of course strawberries are fairly fragile. You don't want to damage them in any way, because they will go bad where you have kind of applied too much pressure and so on. So yeah, there's definitely a lot of different techniques being tested.
Yeah, and I can see it might take a while yet till we know the optimal one. And also the kind of idea where you cut the stem, it kind of is interesting, because I guess it kind of avoids that haptic issue, if you want to call it that. You don't actually have to grab the strawberry or other berry. So yeah, really interesting one. Another question just coming in. I'm interested to know how AI predicting the weather has an impact across all the agriculture industry. So quite a broad ranging one. I mean, I guess I don't want to preempt the panel experts' answer, but it will affect some areas a lot more than others, because if you're growing strawberries in a polytunnel, it's probably less important. But perhaps you'll tell me I'm wrong, because the temperature is still relevant. Anyway, sorry, I'm not the expert. I'm going to shut up and let the people who know what they're talking about answer the question instead of me. Who wants to go first?
Yeah.
Simon.
Yeah, we just started a NERC research program looking at long-term weather forecasts and how that affects the agricultural industry. That's using machine learning and AI in terms of looking at forecasting skill. That's for Met Office, Reading and Oxford. And it's I mean, and having been a farmer myself, I can tell you farmers are very, very interested in weather. And it's really over different temporal spans. So you want to know your short-term weather. You want to know if you can go out drilling or ploughing or hoeing or whatever. So you want to know tomorrow what you're going to be doing, and so you're figuring that out. You want to be knowing medium term, so next week. So if I've got fruit, how many pickers do I need? I need to organise those people, get them in. I need to organise packaging equipment. Then you want to organise on longer term weather. So you might be selling your grain or whatever on the futures market or whatever. You might be having, well, my yield's going to be low, therefore I'm going to do this, that, and the other. So every aspect of what you do as a farmer has a relationship with weather. And all of those weather systems are, well, lots of them are now AI driven. So so yeah, my dad, who was a farmer, he had one of those weather vanes which you tap, and every 7 o'clock every morning I can hear a tap tap tap. It almost
the old barometer.
Yeah.
So in short, Simon, extremely interesting and very useful for all agricultural sectors, I think is your short answer.
Foundation.
Anything that makes weather forecasting more accurate is highly valuable.
Yeah.
Anybody else? Kevin, do you want to?
It's just a small point, really, because I agree with what farmers just said. But I mean, most farmers I know use some sort of weather app on their phone. So, you know, I mean, they have to, by law, for example, with their spraying, they have to record the weather at the time for obvious reasons. And they do that by looking at the weather app. Sometimes they just put their finger in the air and try and work out what's going on. You know, if you're looking at AI, then I mean, again, the AI piece of this, something that don't happen on the farm. What the farmers want is the answer. They want to know what this weather is, and whether it's now or next week or next month or whatever. Whereas they don't really need to get involved in the actual AI themselves. They just want the answer. I mean, we, for example, in Diometer, are integrating with a company, integrating data from a company called WeatherQuest, which is very, very simple. I mean, they provide a lot of data for farmers for this very purpose. I don't know how they get their weather data. I'm just assuming it's good.
Yeah. Okay, thank you. Got another one coming in. Got a few actually. Becky Dodds, Agritech East. What could be the biggest opportunities for AI to make an impact that aren't currently being addressed? So apart from what we're already looking at, where in the future, looking a little longer term, are the big areas? Lars, do you want to say something about robotics? And then I'll ask the other two to say something about AI in the sense of data analytics and predictive models and so forth.
Sure. So I think like AI has the potential to enable robotics on farms. So we have milking robots and kind of manure scraping robots and all that stuff, but those are kind of, they're not operating in the field yet, right? And now we see all these new companies that are trying to kind of make a commercial offering to the farmer to actually deploy these robots in the field. I guess I know in Norway, if I go around and look at farms, I don't see many robots in the field other than the robots that we have deployed ourselves for testing. And I think in a few years, hopefully that will change, that we'll see more and more robots. And AI, of course, the recent advancements in AI and also in kind of accompanying hardware will be what kind of enables that.
Mm-hmm. Okay, Simon, Kevin, other thoughts?
Okay, Simon.
Yeah, I mean, my own view, it's where I was a bit earlier. You know, we know the primary factors driving our crops grow, and you know, we've been doing agricultural experimentation since the 19th century in this country, from the Rothamsted and all these very famous experiments. So and from all that, we understand these primary single factors, which are really the key things that's driving crops. We haven't even started those interactions, and we really haven't. And whilst we think we know a lot about the agricultural system? I honestly don't think we do. I don't think we've even started, or we have started, but we haven't got very far. What AI is going to do is when we get data, it's going to really start to unpick those interactions. And that's how we're going to really learn about system and optimize our system. So I honestly think we're not that far on in terms of understanding how these systems work. And AI barely begun. And so I mean, a lot of people think we know it, but honestly we don't, because we really don't know those interactions. Why is yield so variable from year to year? We think we know, but do we? I don't think so. And I think AI is going to unlock, I really hope it unlocks that.
Yeah. Kevin?
I agree with both of the sets of comments so far. In fact, I would actually just say one particular thing, which is, and to use an example, with Diometer, when I was first coming up with the ideas around Diometer, I think the very first day that I came up with thinking of what is now Diometer, I was thinking about an idea for a new app in farming, right? And then I thought about it and I thought, well, it's not really a very big business. So I shelved it temporarily. Then I came out with another app idea and another one. And I came up with loads of apps and I started seeing other apps coming up. And I think it sort of illustrates the point about AI. There are potentially myriads of applications for AI. The problem is that individually, the development time and effort and cost to actually create them is actually high for the return. So you have to start thinking of things in a bit more of a collective sort of way when you're thinking of these applications and looking at things that can benefit multiple things rather than just one thing. That's all I've said.
Okay, thanks. We're running fairly short of time. I think we've just got about 3 or 4 minutes left. I'm going to go, I think we've got time for one more question, and then I'll ask you each to sort of give a 30-second roundup, perhaps. So, yeah, Brenda Kavanagh at BT, are you looking at AI for monitoring sustainability of pollinators? Something close to my heart as a bit of a bee lover. How are we going to protect the bees and all the other, important pollinators?
It's deathly silence.
Yeah,
I'll fill the gap, but I haven't got a lot to say on it because I'm not directly working on anything in this area at all. But I want to be quite slightly defensive about bees in farming because to some extent, I think there's a lot of reasons that bees have been struggling, and farming is one of them, but it's not the only one by any means. And I think we need to understand there's a bit more to this than just understanding sort of, pointing a finger at farming. But that said, there has to be an opportunity for really understanding that. And I suppose some of the things Simon said previously about understanding agriculture and what the real drivers are and everything else, you can understand more about that by using AI. And then I think one of the benefits could be to look at pollinators. Could be something.
Yeah, I think also, some of the precision agriculture things we've been talking about, weeding instead of putting weed killer down, less use of pesticides, less intensive farming in general can only help, I would assume.
Actually, there is another thing going on as well, which is, we talked about, I mentioned subsidies are all changing. The environmental land management schemes, one of the things they're aiming to do is encourage the environment. So if we're actually paying farmers in the 1970s, we paid farmers to get rid of trees, to get rid of hedges, to get rid of ditches and things like that.
Yeah.
Today, we're paying farmers money to put trees and hedges and ditches back.
Yeah.
Which is somewhat ironic. And it's because of the benefit to the environment. When you add that to the precision farming point you just made, and you start to think of what that means, farmers will be incentivized to do more as well to actually help.
Which will be a good thing. Simon, very quickly.
Yeah, well, 2 minutes. There are robotic bees. I don't vote for them at all. I'll go for the natural bees any day, and it scares me that people are even thinking about it. I agree. We need to understand the system, and bees are a critical part of the system, which we often forget about, and we can use data to put them as part of the system and really, really understand how we can have a natural solution to some of these things, and we don't end up with robotic bees. I think that'd be bad.
I wouldn't in general be in favour.
No.
Okay, I think we haven't got time for any more questions. We've got less than 1 minute left. Would anybody like to contribute a 15-second soundbite just before we close? Simon.
Please, if you're out there, get involved in this. It's fantastic. It's about the future. Everybody always has got to eat, and it's about the environment as well. And together we can make some really substantial improvements. It's a fantastic place to be.
I don't think I can add much to that, really. I'm going to let Kevin say a couple of words.
As I say, ditto to that, and the timing is now as well. Agriculture is about to, or is beginning a massive change, and there is a real opportunity right across the industry in all sorts of different ways, and a large chunk of that is backed up by AI, or will be.
Lars, you've got 10 seconds if you wish to say something.
You know, I completely agree with the other guys. This is the time to get involved.
Yeah. All right. Yeah, I echo that 100%. Thanks, guys. It's been a fascinating session. Thanks all for your input. There's loads of things I would have liked to have touched on, things like the impact of Brexit, vertical agriculture, cultural issues with farmers, how ready they are to adopt technology. Fascinating stuff, and everything we've talked about has been fascinating as well. So thanks very much for your time, and I think we are now exiting. So thanks a lot. Cheers.